Oh, yeah. They did that to my daughter's boots when she was little, and then they did it so tight that we couldn't get them on. It was sort of a pain. Evan, questions? 22? 22. All right. So 22, when I see that, I see a lot of squareds. So we could go with replacing something with something else thing. Or we could do some sort of a factoring situation. Um, but I think I'm going to go ahead and replace sine squared with something else. What can I replace sine squared with? 1 minus cosine squared. So if I rewrite this as 1 minus cosine squared, and then this still stays as minus cosine squared. Yeah, and then I got 1 minus cosine squared, which is 1 minus 2 cosine squared. And I'm done. So Cole, I didn't even have to do anything on the other side for that one. That was amazing. Yeah. Okay. Evan, that makes sense? Yeah, I feel like maybe I helped someone with this yesterday and we did not do it this way, but that's okay. It worked. Holding. I do. Do you? Haha, I have one and you don't. Carly, do you have any questions? No, she's good. Ben Wills? No? 21. It's the computer, man. It's not me. Okay, 21. This is a good one. This is a little bit of a nightmare. Uh, yeah, they all cancel out in the end, but you still have to show all of your work. Okay, so I'm going to FOIL this out. So if I FOIL that out, I get cosine squared t minus 2 cosine t sine t plus sine squared. Okay, you guys know that, right? When you FOIL it out, it's the first thing squared, it's the last thing squared, and then it's the two things multiplied together and doubled. That's the inside and the outside. If I FOIL this out, first thing squared is cosine square root of t. If I multiply those two together and double it, I get 2 cosine t sine t, and then last thing squared. So it's the first thing squared, then it's the two things multiplied together and doubled, and then it's the last thing squared. Yeah, what do you know about that? So this 2 cosine t sine t and that negative 2 cosine t sine t cancel. This cosine squared plus this sine squared is 1. This cosine squared plus this sine squared is also 1. And 1 plus 1 is 2. Yeah, I had a student who tried to do that. He'd write a whole bunch of stuff and then at the end just write 1 equals 1 and be like, no. But, yeah. You got to show your work. Got to show your stuff. You're wrong. You're wrong. Should be minus points for that. Okay, Ben, does that answer your not question? Yes. Okay, Addison, did you have any questions? Which one? Emma? 24. Okay, what do you guys want to do with this? Yep, good. Got two fractions that you're adding together. You need to get a common denominator. Yeah, because our denominator is going to be tangent beta, so I don't have to do anything with that. Yep. So this one I have to multiply by tangent to make the denominators the same, which means I have to multiply the top by tangent also. So that changes the regular tangent to tangent squared. Okay. Now that I have a common denominator, I can write them as a single fraction. I got some squareds in there. That's a clue that I'm probably going to be looking at one of these Pythagorean identities. What's 1 plus tangent squared equal? Secant squared. So that's secant squared over tangent. Now what? Okay, so now we can do 1 over what? Well, let's do all the sine cosine stuff. Right. So let's go 1 over cosine squared over sine over cosine. What do you do when you're dividing the two fractions? Because tangent is sine over cosine. So I'm going to multiply by the reciprocal, so I'm going to flip that over and make it cosine beta over sine beta. Yep, they do. So I got a cosine here that's going to cancel one of these there. 1 over cosine is what? Secant. And 1 over sine is... So, Cole, in honor of your frustration, so far we have not had to do anything to the other side. I think usually you can do it that way. It's just every once in a while you have to, yeah. Yeah. Kinsey, questions? Nope. Okay, Tristan? 25. All right, 25. Okay, so speaking of which, 25, Cole, we do have to use both sides because there's nothing I can change cosine beta into. There's nothing I can change 1 plus sine. I don't have any squares. They're already in, yeah, in terms of sine and cosine. So I'm just gonna cross multiply these things. So if I cross multiply these two together, I get cosine squared. And if I cross multiply the other way together, you guys should recognize that as the factored form of the difference of two squares. So 1 minus sine times 1 plus sine, the inside and the outside will cancel. So it's just 1 minus sine squared. And then 1 minus sine squared is cosine squared. So we're donezo. Glory, did you have any questions? Okay. Okay, will you guys pass those forward? Okay, so I don't know if you ever wondered this. You probably didn't. But so far, we've only been able to take the sine and the cosine and the tangent of certain angles based on 30, 60, 90 triangles and 45, 45, 90 triangles. So I don't know if you've ever wondered, like, how do you find the cosine of 50 degrees? Or how do you find the cosine of 20 degrees? What if it's not one of those or a multiple of those things? So that's what we're going to tackle in this section, okay? Sadly, if you want to find the cosine of two angles being subtracted, you don't just find the cosine of each and then subtract those answers. In other words, what I'm saying is, if I wanted to figure out the cosine of 75 degrees, I can't say the cosine of 75 degrees is the cosine of 60 plus the cosine of 15, because those two things are not the same. Okay? You see how that does not work? This answer right here is not the same as that answer right there. So you can't find the cosine of things being added or subtracted by just doing the individual pieces. So we have formulas for that instead. All right? So the first one that we're going to start with, for whatever reason, is if you want to find the cosine of two angles being subtracted, the formula for that works out to be the cosine of the first angle times the cosine of the second angle, plus the sine of the first angle times the sine of the second angle. And Emma's response to that formula is appropriate. It's a pain, Emma. You're not wrong. I got the big eye roll out of that. We don't have the sine one yet. I'll give you the sine one in a little bit. Yeah. And there's different for adding too. Yeah. This is a cosine of two angles being subtracted. Okay? All right, so the reason why that's useful is because let's say that we wanted to find the cosine of 15 degrees and we wanted to find the exact answer, and we were in a college math class and no calculators were allowed. Well, you know 45, 30, and 60, okay? So what two angles subtracted equal 15 degrees? What two angles that we know can you subtract that equal 15 degrees? But I don't know 75, so that doesn't help me. 45 and 30, okay? There are other ways that you can do this which would also work. You could do 60 and 45. But 45 and 30 will be fine. So what I'm going to do is I'm going to change the cosine of 15 degrees into the cosine of 45 degrees minus 30 degrees, and then I'm going to use that formula on the previous slide to figure out what that is. Okay? So the cosine of 45 minus 30 degrees is the cosine of the first one times the cosine of the second one. Was it plus or minus? I don't remember. Plus, thank you, the sine of the first one times the sine of the second one, okay? And now if you were stranded on a desert island, you could do this because you can draw 45, 45, 90, and 30, 60, 90 and figure it out from that. I'm not going to make you draw those out. You guys have the circle chart that you can just look these up on. What is the cosine of 45 degrees based on your circle chart? What is the x-coordinate that goes with 45 degrees? Root 2 over 2. What is the cosine of 30 degrees? You could look up here and go adjacent over hypotenuse. Root 3 over 2. Plus, what's the sine of 45 degrees? Root 2 over 2. And what's the sine of 30 degrees? 1 over 2. Right? So this simplifies to square root of 6 over 4 plus square root of 2 over 4, which we can write as root 6 plus root 2 over 4. Can't combine those square roots because they're not the square root of the same number. Okay? So, ugly. Yeah. Root 6 plus square root of 2 divided by 4. Not very pretty. Not difficult. No, you just have to kind of use the formulas. But it's not like an answer like in the old days when you got an answer of 7 and you're like, okay, whole number, I'm probably right. You're never going to get square root of 6 plus square root of 2 over 4 and go, oh yeah, that feels right to me. I think that's good. Yeah. Braden? Yeah, you're right. This? Oh yeah, I used this yesterday. No, in my everyday life. I was making dinner, And I had to figure out how much spaghetti to put in the pot. And it was only my wife and I. And so I made a diagram, and then in the diagram there was a triangle that it was like cosine of 15 degrees, and I had to. Okay, so the other one is the cosine of two angles being added together. It's the same thing, but this time you subtract them. This is cosine addition formula. Don't worry about it. It never happened. You didn't see a thing. So the cosine of two angles added together is the cosine of the first one times the cosine of the second one minus the sine of the first one times the sine of the second one. Okay? So that's formula number 2. I don't know why they started with minus and then did plus. Of course they can't. No, plus is minus and minus is plus. Yeah. Did I tell you guys the one time I used trigonometry in my real life? I was so excited. I was No, I was painting my house, and my garage roof is slanted like that, and I was painting this wall, and every time I put the paint can down, it would like slide down the thingy. And so I was like, okay, I'm going to build a little table with no legs on this side and legs on this side, and the legs are going to be the angle of the roof, so then it'll be flat. You got me? You don't understand? So then I just took a little piece of plywood, and I had 2 pieces of wood, and I just took them and I cut them at this angle, and then that gave me this little thing that I could set my paint can on, and then it wouldn't slide down the roof, and my paintbrush and stuff like that. But I had to figure out what angle to cut the legs at. And so I literally, on my roof, measured like this distance and then this distance or something, and then I did the math and figured it out. Yeah. You know what the dumb thing was? 22.5 degrees, half of a 45. Like everyone knows that who's like a roof person. They would just look at my roof and go, yeah, 22.5. Whatever. I was excited though. It worked perfectly. Yeah, right. Okay, the sine one is the same thing, but it's the sine of the first times the cosine of the second. Yeah, it's both. Plus the cosine of the first times the sine of the second. And so the plus and the plus line up and the minus line up. So the addition is addition in this case, and the subtraction is subtraction. Okay? So if you want to write it out as 2 separate ones, the sine of 2 things added together is the sine of the first one times the cosine of the second plus the cosine of the first one times the sine of the second. The sine of 2 things being subtracted is the sine of the first times the cosine of the second minus the cosine of the first times the sine of the second. So you can write it as one formula, but if that's a little bit confusing, yeah, you got to put a little tail on your U's. Pro tip. I mean, I got it right. I got the right answer, 22.5. The thing worked. It solved the problem. I was going to market them. It was really sweet. It had this little fold. I put little hinges on it, so little fold-up legs. I thought, I mean, lots of people have to have this problem. Like, look at them over there. They got that little porch, and they're going to stand on that porch and paint the thing. That roof is probably 22.5 degrees. What? Put little rubber feet on the legs so they wouldn't slide down the thing. I could do custom ones. You just tell me what degree is, and then, or I could be just like take a picture of your roof if you don't know how to figure out the degree yourself, and I'll figure it out for you. That's extra though. That's $10 extra. No, I want to do it for them, and yeah, charge money. $50. That, why would I be, why would it be wrong, Shelby? What are you saying? And they're wrong. Okay, so let's do another one here. Nope, let's not do tangent. Um, let's do the same thing we did before with sine. So what did we do? The cosine of what? 15 degrees. Let's do the sine of 15 degrees, shall we? What do you want to break that down into? 45 and 30 again? Okay. Yeah. So this would be the sine of 45 minus 30. So according to that formula, that is the sine of the first one times the cosine of the second one. And minus stays minus, right? Cosine of first one, sine of the second one. Okay, so sine of 45 degrees. I don't think so. Root 2 over 2. Cosine of 30. Root 3 over 2. Cosine of 45. Sine of 30. 1/2. Weird. Was the other one the square root of 6 plus the square root of 2 over 4? Except this one subtract. If you do 60 and 45, you get the same answer. Yeah, you want me to do it or you just trust me? Okay. It works. You can do whichever one you want, whichever one works. I know that if I'm going to do the sine of 15 degrees, I can't use addition because I don't know two angles that add up to 15. I have to choose from 30, 45, and 60, right? So I can't add them together. But if I had to do like 75 degrees, then I would do addition. Then I'd go 30 plus 45. 25 degrees, you'd have to do it multiple times, and we're not going to get into that, no. Yeah, this will be on the quiz tomorrow. Yeah. What? Quiz.